In this second module of Chapter 4 on reproduction, Module 4.2, I will cover computation of per capita reproductive rates, including daily and lifetime rates, mean ages, and age-specific rate generalizations. Consider this table containing information on age-specific egg laying in the Mediterranean fruit fly. In the top row, we have exact ages from 40 to 43 days for each column. The first row is number of females alive at age X from 360 out of 1,000 to 297 out of 1,000. The next row is the number alive at the midpoint interval at each of these ages. These range from 352 individuals alive between 40 and 41 to 310 alive between ages 42 and 43. The next row contains the number of eggs counted at these exact ages. We see that there were 5,616 eggs produced by the cohort in the interval 40 to 41 and 4,713 produced by the cohort between ages 41 and 42, and so forth. The next two rows are specific age intervals and the age index applying to the intervals. The following row is the midpoint survival, specifying, for example, that 352 individuals, or 0.352 of the original cohort of 1,000 flies, were alive at the midpoint of this first interval. Likewise, 0.333 would be computed from the dividend of 333 flies alive at the midpoint interval between 41 and 42 in the initial 1,000 fly cohort. The final row is the net maternity, computed as the product of LX and MX, yielding 5.6, 4.7, and 4.3 for the intervals 40 to 41, 41 to 42, and 42 to 43, respectively. The formula for the per capita reproductive daily rates would be MX equal the total offspring produced from X to X plus 1, divided by the number of individuals alive at the midpoint of the LX would be the number of live at X plus the number alive at age X plus 1 divided by 2. The key formula for these various rates are given as follows. Gross reproductive rate, GRR, is the sum of the number of eggs at each age, and the net reproductive rate is the sum of the product of LX and MX. The eggs per female per day is simply the net reproductive rate, NRR, divided by E naught, the expectation of life at age 0. This table contains example data and computations for these various metrics for Drosophila melanogaster. We look at each of the 6 columns. The first column, column 1, contains age X in days from 0 to 83 for this particular experiment. Column 2 contains the number of individuals alive. This would be the number of living starting with 666 and ending with 0 83 days later. Column 3 contains the total number of eggs counted for all alive flies, starting with the pre-reproductive period of 2 days and ending with the post-reproduction for 2 very old flies. Column 4 contains the familiar LX schedule, starting with the radix of 1.0 and ending with 0 flies alive at age 83 days. The sum total of this LX column is 38.3, and therefore, based on the formula for expectation of life given in Chapter 2 on life tables, expectation of life at age 0 is 0.5 days, or a half a day, less than the sum of the LX. And therefore, expectation of life for this cohort is 37.8 days at eclosion, or birth. Column 5 contains the per capita egg laying at age X, MX, computed as the total number of eggs laid by the cohort at age X, that is column 3, divided by the number of living from column 2. The sum total of 1,332 for this cohort is the cohort gross reproductive rate. Column 6 contains the net maternity function as the product of column 4, LX, and column 5, MX, the sum total of which will be the net reproductive rate, or 1,033.5 eggs per female. A final computation is determination of the number of eggs per day per female. This equals the net reproductive rate divided by the expectation of life, which yields a value of 27.3 eggs per female per day. I will close this module by noting that the same analytical framework presented here for reproduction can be generalized and applied to any age-specific metrics. Using the notation GX, it can be applied to activity at age X, feeding rate at age X, mating at age X, and so forth. So we have a gross rate as the sum of GX over all ages, the net rate, the weighted by LX, the average daily or yearly rate as net rate divided by the expectation of life. And the timing for each is computed by weighting the terms in the numerator by age X. This ends this module 4.2.